In this video, we're going to use the epsilon-delta definition of limits to understand one-sided and infinite limits. It says, what values of delta are an appropriate choice when proving the following limit? And they give you the limit as x approaches 6 from the right for root 2x minus 12 equals 0. Let's look at the epsilon-delta limit definition. It says that if we have this limit as x approaches a of f of x equal L if for any epsilon greater than 0, so for all epsilon greater than 0, there exists a delta greater than 0 such that if 0 less than absolute value x minus a less than delta, then the absolute value of f of x minus L is less than epsilon. So this part here is talking about x values, meaning that there exists some x values that are really close to our limit a, or not our limit a, but our x value a that we're trying to take the limit at, that would produce a limit or a value that is really close to the limit that's within a tolerance of epsilon, essentially. So we're going to use these two pieces to prove this limit. So we're going to start by saying that we want to prove that the limit as x approaches 6 from the right for root 2x minus 12 is equal to 0. And they tell us a few different things here. We know that the limit is equal to 0. We have our function, which is root 2x minus 12. And we have our a value, which is 6. I'm just going to say it's 6. It says 6 from the right, but we're just going to use 6. So we're going to then start by saying if 0 is less than the absolute value of x minus 6, which is less than delta, then the absolute value of the function root 2x minus 12 minus the limit, which is 0, is going to be less than epsilon. So if this is what we want to have happen here, we're going to start with what we want and work our way backwards to find this delta, which is what they're asking us for. So we subtract 0, we get the absolute value of root 2x minus 12 less than epsilon. If we're taking the square root of some number, you have to take the square root of positive numbers, so this whole thing is going to be positive, so we don't really have to worry about the absolute value signs here because the number inside will be positive. So we can drop those and say the root of 2x minus 12 is less than epsilon. Square each side, and we get 2x minus 12 is less than epsilon squared. Factor a 2 out, and we get x minus 6 less than epsilon squared. And then we can divide by 2 on each side, and we end up with x minus 6 less than epsilon squared over 2. Now, if you notice we have x minus 6 here, and in this piece we have absolute value of x minus 6. We're going to drop the absolute value signs on this piece because we're approaching 6 from the right, which means that we're going to be using numbers like 6.01 and 6.02. If you plug that in to x here and subtract 6, you're going to get a positive number anyway, so we don't really need the absolute value signs. So at this point now, we're going to choose our delta value then to be equal to this epsilon squared over 2 value. Because we're saying that x minus 6 has to be less than delta, that means delta's greatest value, we're going to say essentially, is going to be this epsilon squared over 2. And once we choose that, then we're going to try and prove that go back and prove that this piece here is actually just less than epsilon, but we're going to do that using delta. So we'll start by saying the absolute value, or we can say even check, let's say that. We're going to check that the absolute value of root 2x minus 12 minus 0 is actually less than epsilon. And to do that, we're going to start with this piece on the left, and we're going to say that that is really the root of 2x minus 12, absolute value, which is equal to, if I factor out a 2 there, I get the absolute value of root 2 x minus 6, which, if I'm taking the absolute value of a square root here, I'm going to get a positive no matter what, so I don't need this absolute value sign. So I'm going to say that's really equal to the root of 2, parentheses, x minus 6. And then notice I have x minus 6 less than delta. And I chose delta to be epsilon squared over 2. Well, at this point, I'm going to say that this then would be less than the root of 2 times delta, because delta is supposedly larger than x minus 6, so that makes this thing less than this piece, which then means that this is actually going to be, we're going to say that that's equal to root of, if I plug in the epsilon squared over 2, which is our delta, I'd have 2 times epsilon squared over 2, which is equal to, when I multiply here, that the 2's cancel, so I get root of epsilon squared, which is equal to take the root of epsilon squared, I get epsilon. So we just proved that using delta as epsilon squared over 2, we actually end up being less than epsilon, because we, at this point here, we got that less than piece, and all these other pieces are equal to that root of 2 delta. So we proved that this piece was less than epsilon when we chose this delta being epsilon squared over 2. So we actually proved this limit. What did they ask us for? They said, what would be an appropriate choice? We would say that delta equal epsilon squared over 2. That was the appropriate choice.